This video is part 2 of the Math 7 Interim 1 from 2017. We're going to work on 7RP2. If you're going to search in Khan and get extra help with this, that would be 7th grade ratios and proportions, determining proportionality with a graph. So the question from this page is on page 3 of your interim, and it states, a recent study claimed that in any given month, for every 5 text messages, and it says for every, so that tells me there's going to be a rate. For every 5 text messages a boy sent, a girl sent 7 text messages. Is there a relationship between the number of text messages sent by girls to the number of text messages sent by boys? So that's telling me there's a rate or a ratio going on. So there's something to something else. In this case, what are we comparing? Text messages sent by girls to text messages sent by boys. So that tells me that it is the number of girls text messages to the number of boy text messages. So now we know we have a rate. And it says explain your reasoning by using evidence from a graph. So this target is about graphing itself. I could solve this other ways, but I am going to show this using a table like they asked me to and creating a graph. It says it's optional to create a table, but I think it's really important to show that table. Your credit is not going to be taken away if you don't have a table as part of your evidence, is what that means by optional. So I know there are 5 text messages a boy sent and a girl sent 7. So let me make a table right here. We have, let's use B for boy and G for girl. So here's girls' text messages, and here's boys' text messages. Notice on the graph we're going to put X and Y. We're going to keep track of our Y over here and our X over here, but I'm going to use G and B just so you can keep track of what we're talking about. So it says for every 5 text messages a boy sent, so we have 5 text messages from a boy, a girl sent 7 text messages. So that means for every 5 boys, there are 7 girls sending text messages. Oh, I'm sorry, I said that wrong. For every 5 text messages sent by boys, there are 7 text messages sent by girls. Now I know that I could say, what if I were to double the number of boys? So let's say we have 10 boy text messages. That would mean I could double the girl text messages and make 14. I could also triple 5 times 3 is 15. So, and this is going to remain proportional. It's going to be 5, or 7 times 3 is 21. I could keep on going. There's other ways I could do this. I could also multiply the 5 times 6, and I could make 30, or I could think of it as doubling 15. So no matter what you do, if I multiply the number of boy text messages by 6 to get 30, to remain a proportional relationship, I'd have to also have the same multiplier by the 7. So 5 times 6 is 30, 7 times 6 is 42. And we can continue going on infinitely. But if we increase the number of boy text messages, we'd have to increase the number of girl text messages. Let's put this on a graph. So we're trying to, by the way, show the relationship is proportional. One way to do that is by graphing. So on my x-axis, I'll put number of girl text messages. And on the y-axis, I'll put number of boy text messages. So I'm going to graph 7 girl text messages and therefore 5 boy text messages. 7 girls to 1, 2, 3, 4, 5 boy text messages. 7 is the x, 5 is the y, 7 is the x here, and 5 is the y there. Another point, 14, 10. 14 girl text messages, and I'm going to speed this up a little bit. I'm going to go up and estimate and then make sure it's right. So that was 10 for boys and 14 for girls. I'm going to do this one, 15, 21. 15 is the boys. Keep track of which is the y and which is the x. So 15 for the y, and we're going to go over to 21 for the x. Be really careful. And I'm going to always double check. 21 for my x, which is girls, and 15 for my boys, which is y. Let's do this last one. 42 is the x. Notice I get to 25 and there's no more room on this graph that was given. That doesn't mean that point doesn't exist. It just means that the x-axis was only labeled up to 25. If I was given a blank x-axis, I could have chosen whatever scale I wanted. But notice the scale's counting by 1, 1, 1, 1, 1 every time. So I'm not going to get up to 42 in the space I have. But I do notice that there's a straight line that I could draw. So I'm going to cheat with my tools here, and I'm actually going to draw a straight line with my line tool. You, of course, would use a ruler on your paper. Notice that if I draw a straight line through the origin, it goes through 1, 2, 3, all three of those points. And then there is a point right here at 0, 0. And that point means that for 0 text messages from girls, there would be expected 0 text messages from boys. So this point right here is the point 0, 0. So when we define a relationship as proportional on a graph, we say it is a straight line that goes through the origin. Just fits both of those characteristics. These 3 points lie on the same straight line, and it goes through the origin. And like we talked about, that line does go on infinitely. It's just our x-axis stops at 25, and our y-axis stops at 25, so we can't graph the extra points. So this point right here exists somewhere way up here on this line. So if I were to write an explanation, what would that explanation be? I'm going to scoot down here. Let's double check the question. It says, is the relationship proportional? Explain reasoning using evidence from the graph. So I can't use the evidence from my table. I have to explain from the graph. So I'm going to say the relationship between girls' texts and boys' texts is proportional because the graph of the line through my points or solutions is a straight line through the origin. I could have said that a little shorter. I could have said the graph is a straight line that starts at 0, 0. I could have said the line is straight and goes through the origin. Essentially, this is the most full sentence I could use. I'm telling what the context is. I'm also explaining those two qualities, straight line through the origin. The last question on this standard shows us 6 different graphs. And for those 6 different graphs, the question is the same. Which graphs show quantities in a proportional relationship? So remember how we just defined that. If we're looking at a graph, we're looking for a straight line. And we see that it goes through the origin, which is 0, 0. By the way, the reason it's a straight line is because when we have any 2 values that use the same constant multiplier, that means that as one value increases, like x-axis value increases, the y-axis value will increase as well in a proportional manner, so by the same multiplier every single time. So let's take a look at this one. Is this one a straight line? Yes, it is. It is straight. Does it go through the origin? No, it does not. So this one is not proportional. And we could also, if we wanted to dig a little deeper, put some points on here. 0, 3 is a point. And we also have the point 2, 3. So notice that 3 over 2 and 3 over 0, those are not going to produce the same value. 3 divided by 2 and 3 divided by 0. We're not even going to talk about divide by 0 at this moment. You're going to find in a calculator that wouldn't even work, but that's a whole other story. The fact is there's not the same k value. These k values, no, they're not the same. There's no constant proportionality. On this one, there is a straight line, and it does go through the origin. So yes, we're going to circle this one. This one is proportional. On this one, it does go through the origin. Great. It's one of our requirements, but is it a straight line? Notice how it starts to curve up, 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 up. That straight line would have looked like This, for example, if I'd done a really good job, that is not a straight line, so that one's not proportional. This one has a point at 0, 0, or a solution at 0, 0, and is a straight line, so yes, that one is proportional. This one's close, 0, 2. Nope, that does not go through the origin. And I can show you a little more evidence here. Here's another point. Let's look at this one, 8, 6. There's 2 points I found. You don't have to give this much evidence for this problem. It didn't ask us for it, but I just want to make sure you're understanding that there's more than just those 2 characteristics. If you dig a little deeper, you can see something more. So y over x, 6 over 8, and then, oh, I did that backwards. Nope, I didn't. Y over x, and 2 over 0. And I can look at one more. 4 over 4. So 4 over 4 equals 1, and 6 over 8, that does not equal 1. I just know that by looking at it. 8 over 8 would be 1, or 6 over 6 would be 1. So I can already say that there's no k, there's no constant of proportionality here. And the last one goes to the origin and is a straight line. That one is proportional. So B, D, and F all have a point at the origin, and all are a straight line.